you can do office hours before the 27th of November, or send on the 9th, 10th, 11th, and on the 12th is the exam in the morning. The exam is 1.5 hours. This guys will check more time. You get 2 hours, I think. You calculate when it comes to next year you wish, but it's actually already doesn't make a difference.
I was going to say, like, the exam is on the 12th. Friday 12th. And we do on Friday 5, the 5th, it could be econometrics, finance. I don't know if you want to do it the 8th, maybe. It's the Monday of the week that we have.
No, 8th is Friday.
It's a holiday.
Not Tuesday, 9th.
So 9th.
9th.
Would you all be okay with doing a Q&A session on the 9th?
9th in the morning?
The Q&A session.
Yeah. 9th in the morning?
9th. Okay, so, yeah, I'm going to put you by.
Please, yes. And also towards the guys which are not here, that they also know. But then it's good because if they can econometrics, you also are not here, it's all econometrics. And after I'm here. Then probably I will send my office hours maybe on Tuesday afternoon or Wednesday for sure, and maybe also Thursday. Maybe if there's Q&A on Tuesday and office hours on Wednesday, Thursday. Wednesday, Thursday.
Okay.
Then I will just get them under. So, you know, say Monday 15th. Okay, just to make sure, because I talk about this with the retake exam. So in general, well, since I'm grading on a curve, it's not so difficult to pass, even if you're not doing too well, but then again we will see, sometimes people fail. If you fail, there is a retake exam early in January. So I think you will have the 6th is the last holiday, 7th is not lecture day, which is a Thursday, I think. No, it's a Wednesday. 4th is a Sunday, 4th of January.
7th is Wednesday.
7th is Wednesday, so Friday, you start on Thursday 8th. So Thursday 8th, Friday 9th are already lecture days for the undergraduate at least. I don't know if it's the master your class or not.
Yeah,
8th you start. 8th, 9th. So I will probably take something, not 8th, 9th, but 10, 11 on the 12th of January or something, will be the retake exam, if somebody fails. So this you will know, I will try to finish your grading on the 12th, latest on the 13th, on the 15th in the morning. So I will publish the grades and send you an email. If you want exam revision, let me know also by email. And then the retake exam will be on the 12th of January. So in case you fail, you also get an email from the personal email to choose between 2 options for the retake exam. One is an exam like in December, where you get a grade from 0 to 10. We have new questions, so always one of the questions you will be familiar with, because you've seen it before. I uploaded the old exam, from the old exam, or one of the problems, so one question you will be familiar with. Second question is like intermediate, and the third question is difficult in the exam, and you can get some similar exam again for January. In the retake exam, so again from 0 to 10 on the grades, and for me this will be the exam I can put maybe next year to the next year, so for me it's an extra effort, but it's the next year's exam or in 2 years time or something, so we'll need some extra effort, but it's something I use up for. Or you get an easy option. The easy option is 50%. You get questions you all know, you've seen before, from different ways, from the exam of December, or from the problem set, or from the old exams that I uploaded from last year. But then you only get a pass or fail grade, which is a 5 or a 0. Okay? So you will see. It's just for you to think about it and make up your mind in case you need it. But so you have the idea. Then in case you get the emails, and then you will only on the 15th in the morning, if I grade it, you get, in case you fail, you get these emails and you are
So when you're going to have the test graded by?
Monday 15th you get the grade.
No, December.
Because I'm going on the 15th to conference in the afternoon, or 16th in the morning. 15th in the afternoon, undergrad exam. 16th I'm going to a conference until Friday, and then it's Christmas holidays, and everything is closed. So I will finish your grading before the holidays. And then we'll have this email on the 15th. And you have to choose probably by the end of the week. And then the 15th until the 20th or something 19th, you let me know please which option you choose. You reply by email, so it's fixed, and we fix the exam date, which will be January 12th or something, January 12th or something, and depending on the schedule. Okay? That's for you to know. This is how it works. And if you fail a second time, in principle, you come back next year, you have to do the subject again. So. Okay. First test. The second thing. With the problems at 1, I told you, well, if you have the solutions and use them wisely, one person copied literally what I wrote in the solutions, including my mistakes. So I stopped correcting it some other time because there's so many people who are just copying some of the solutions. And this is not how it works because I'm not checking whether you copy correctly my solutions. Sorry, since they were already available in September, still the solutions that from last year. It probably disappeared at some point in time, but too late, so some other people already downloaded it. So there was one I stopped correcting. Okay? Because otherwise I would have to give 0 to someone maybe, and this is unfair. I just said if you have the solution, you copy the solution. So for what is it, please take this without no literal copy of my solution. If I see this again, it's a 0 for the problem. Second thing, if you copy them, use the solution in a way that you do the problem set by yourself, because in the exam you will have to do the problem set without the solution. So you have to study how to solve this without the solution. But then after you can check whether it's correct, but take into account that well, as you solve problems at once, I mean, got it. But there was some mistakes in the solution. Or the solutions are very short. So there's no development sometimes indicated. If there's no development, well, you need to get the solution, you have to do some kind of development. If you are calculating how you get to the solution, if I don't see this again. Okay, so please, for problems at 2, be more, P was put in Spanish, so I have to be a bit more clever. Some of you did well, but okay, now the question is as a group, do I punish you or not, or is the people, somebody has decided problems at 1,000? And for everyone, then nobody has to disappoint. Something about 1. I told you before a bit more regularly, but now it's clear. Okay, so this is for problems at 3. Although there will be new questions, so some of the solutions will not work, and so on. But be careful with this, especially with respect to the final exam, because in the final exam you don't have the solution, so you need to know how to do it by yourself and know how to do the development.
So what's going to be the format of the final?
Yeah.
The format.
3 questions.
2 questions.
1 hour and a half. Similar to the problem sets, but the ones which are intermediate. The most difficult is not, the easiest ones easy. Problem set 1 and first questions are very, very easy. So this one doesn't be important. This is for you to repeat the utility function that's on. Okay. And then, well, what I do is the grading, since there are 3 problem sets to grade, so each of the 3 problem sets left, 2, 3, 4 will count 10% of the problem set grade. 70% the final exam in December. Okay, now let's keep going with the content of the subject, which is delta zero. So we have finished general equilibrium on Monday with the production stuff as well. So we saw with production that these Barcelos, Ryczynski, Hexaholins theorems, and this stuff is really applied in macroeconomics and international trade, so this has been useful when this setup works for production as well. But we are doing more of exchange economy, and when we go back to this exchange economy more, you will see later in chapter 6 and chapter 7 also will be more exchange and production. Okay, so the first thing is, so markets, these weather theories are about the efficiency of markets, about the Pareto efficiency of markets, and Pareto efficiency of markets is something very positive in terms of economic thought, because by positivity means you cannot improve anybody's situation without harming someone else. You are kind of at that optimum from an economic point of view. It doesn't say about distribution of resources or wealth, because equity we don't say anything about, but it only says that all resources are distributed. And this Pareto, and all resources distributed, nobody has spare resources, nobody claims resources that do not belong to anybody. And this is the first theorem, which says if references are locally non-separated, and if x star p is over rate equilibrium, then the allocation x star y star is very optimal. And this is a very positive result in terms from economic point of view, because it says that markets are efficient. We just need people to let maximize utility, firms maximize profits, and then you get market theory, and this is very optimal. So this is very, very good, very positive result in terms of economic point of view. Now, what's the problem with this? In reality, this doesn't work, because for various reasons, many of the assumptions we make are not fulfilled, and we will start from various angles. Chapter 6, we will talk about externalities and public goods. In case that externalities are public goods, these other assumes do not apply, that you get some different solution. These also economists found out quite fast, after establishing this delta theorem, so they found out externalities are public goods, you cannot apply the evaluation equilibrium framework, unless you do some adjustment. And the market outcomes are not anymore efficient. Second, one of the assumptions, for example, with production is that consumers own the firms, which in the model obviously works, because the consumers own the firms. In reality, some of us have shares, there are very some people which have more shares, which are the rich guys, and they own huge parts of companies, so they derive much larger profits of companies. Most of the workers which are having, I don't know, normal guy on the street in Barcelona will probably not have many shares. Maybe as a pension fund, but in general you will have some deposits, some money in the bank, that there will some interest, but you will not have many shares. So this is a risk. And then clearly, now it's a trade-off. Right? Increase the wage, in the model it doesn't matter, because the firm makes lower profits, so as a shareholder I get lower profits, but as a worker I get higher wage. If I lower the wage, I get a lower wage as a worker, but I get a higher profit as a shareholder, so I don't care. But in reality, this trade-off is not. There are many things which don't work in this way. In reality, the other thing is also, like one of the assumptions, underlying assumptions are these preferences are often non-scientific, basically rational. So if you have people which are perfectly rational, you can get this outcome, but in reality people are not. So then you go to experimental economics, for example, behavioral economics, where in economics what we do is we have students in the lab, we let them take economic decisions, and then we see whether they actually comply with what we are supposed to propose in theory or they behave. And the others no, they don't behave like we propose in the theory. So certain patterns of behavior, human patterns of behavior, which are different from this rationality which we assume in the model. Clearly, people don't behave rationally and applying the models leads to an outcome which in reality is not the outcome we observe. People are behaving differently. And then this branch of economics, which is behavioral economics and experimental economics, where we deal with this. Where we see how people actually in reality behave, to understand how should we adjust our thinking about the reality in terms of economic outcomes. But in principle, so the outcome is very good. When we say anything that's very limited or in the market, the good is what we are pretty often. The second fundamental theorem of further economics is complementary to the first, which is now, which we have done in one exercise. So that I fix one desired outcome. So we can fix one rate of an allocation, and then we can get this as a valuation equilibrium by redistributing the initial allowance. So this is, you fix the solution you want to take, equilibrium. If it is very efficient, you can then via taxes, via redistribution of wealth or initial allowance in the economy. Afterwards, let the people with the new endowment you want to get them, they do the general equilibrium and you get the automation, which is a desired one.
Always.
Well, always, there are many assumptions. So, see. Here's a few assumptions. This is totally non-saturated, and the irrational preference is totally non-saturated. This is strong assumption, but here is a large assumption. Okay, so consider an economy as we have it usually specified by this statement is a bit longer. These are the consumers, and the firms, the endowments. Okay. And then we have this every chain and production set and preferences in context. And you want preferences locally non-saturated. Then, for every Pareto optimal allocation, X star Y star. With X star being such set, and this is important, every consumer consumes a positive amount of each good, so we have an entire interior solution. X star being such that every consumer consumes good. So carrier point. And for every there is a price vector, so for every Pareto allocation, there's a price vector, P not equal to 0, and X star Y star. This is valuation equilibrium. Okay, so this is now this redistribution needs to redistribution of additional endowments makes you, or then you get it according to the price vector, you can implement any Pareto allocation in the material as outcome of this. A bit more something.
We only define preferences for excise because we assume that whatever we don't spend in excise, we spend on one thing.
No, this is capital XI is the consumption set.
That's
So for each consumer, the entire consumption set and preference. So the consumption set is everything you define. Because YJ is production, so this is what the firms produce. So if both of these, you have not only exchange, but you also have production. So everything all becomes firms. Okay, so basically, Waller's law just briefly means that there's no excess demand, which is something you should have heard of, but it's not really set in code. doesn't work optimal, but it's based using this assumption. So again, the key value added for you will be to understand the theory, how it predicts outcomes, and on what assumption this is based, to understand if you change the assumptions, how the outcome changes. And sometimes you at the end of the master, you should be careful to see through these models to understand what the assumptions give you. Which part of the results are due to the assumption. And if you change these assumptions, relax them, you make them more realistic, what would be the corresponding outcome? So the first step in this course, and the ones you have in this semester, is more the basics. So here you get all the theory, all the hard stuff, to understand how these models work. And later, from January on, you get the economics subject stuff, which is more like how it would, like you relax these assumptions, you see how it works, you get more models, more smaller models in microeconomics, what will economy, and then you get a better feeling than for the second part, which is if the assumptions are not fulfilled, what do we get? Here it's basically, if you have these strong assumptions, what do we get? But these are very that these assumptions are maybe not realistic. And in general, you get, if the assumptions do not hold, what type of things you get? Models and then reality. And the first thing we do in this first step in this direction is to we have externalities and public goods. So in case we have externalities and public goods, even in this very theoretical setting, you also get still, well, that these two delta zeros do not apply, but we still can find a solution with the mathematics framework with this very theoretical thing. Now let's start with externalities. Well, if there are externalities in the market, then the valuation equilibrium fails to be Pareto efficient in channel. By chance it might be, because two different things cancel out. There's externalities. So valuation equilibrium fails to be Pareto efficient in channel. Good. Where do the externalities play a role? Consumption externalities. One agent's consumption affects another's utility. And the basic examples are smoking, loud music, noise. Then there will be consumption externalities. Then you also have production externalities. This one firm's production affects another's production front. Production.
So what is this there? Consumption externalities are
One.
consumption. Down there, agent consumptions affects and
One
down
agent's consumption affects another's utility. Then production is one firm's production affects another's production has to be production front. And here's a classical example which you will find in the textbooks. Is the lake versus the capital factory, it's a fisherman, the capital factory will be the lake, and then the fisherman can catch less fish. Okay, very simple, but this is a classical example. But in general, you can also think about other stuff, so but you have many probably production externalities with pollution. also happen. There would be some production externalities that affect the consumer, but we will have to. Okay, then we will see. So let's do an example for A, and later on we have always in B somewhere. So example for A, an abstract one. Suppose you have two agents with two goods and negative externalities in the consumption of X. Negative externalities in the consumption of good X. So what we get is the derivative of the utility of consumer 2 with respect to the consumption of X1, so consumer 1's consumption of good X, is negative. While U2X2, the derivative is positive, more consumption gives me a larger market utility. If consumer 2, so consumer 1 consumes more X, this affects consumer 2 negative. And for the consumer 1, the same. Without taking into account the externalities, so in the variation equilibrium without intervention, without taking into account these externalities, both agents maximize their utility. Subject to a Watson constraint, like we did in chapter 4. So you just maximize your utility and the demand functions. You don't take into account that there is certain this negative exponent on the other agent. And then you get first order conditions, which are like usual ones. The marginal rate of substitution for consumer 1. So it's X and Y. The price ratio, and this is the same for the second consumer. So the externality is not explicitly considered. What else we can do? The social planner could maximize the total utility of these two consumers in the economy, and then we would get a better solution because he can take into account this externality and allocate the consumption of the goods X and Y optimally. And probably would put less weight on X because this harms, they get positive utility by consuming their own X, but negative one on the other's consumption of X, so you would reduce this consumption of X and increase the consumption of Y. The next step is if you select social planner. Total welfare, so the sum of utilities, welfare, what we could do is the following. Either he maximizes the sum of utilities, or he maximizes one consumer's utility, keeping the other consumer at a certain level. This is what I propose here. But they also maximize the sum of utilities with the constraint, the resource constraint of the economy. Now let's maximize one X1 it does negatively because of this externality, in consumer 2 utility function, and X2 it does negatively in consumer 1 utility function. Okay? Then we get some first order conditions for this mu problem, this mu being the constraint multiplier here. Well, consumer 1's this one minus Q1 2 with respect to X1 minus mu times U2 X2 minus U2 U2 X1 equal to 0, and we get the y derivative of U1 with Y1 minus mu U2 equal to 0. Here you can solve for mu from the second equation, which is just the ratio of marginal utilities, which tells you how what is the best outcome in equilibrium for the ratio of marginal utilities, which is given by this limit u upper bar. So if you relax the constraint by 1 unit, which means you give consumer 2 1 extra unit of utility, you allow him to get 1 extra unit of utility. This is by how much the objective function goes up, which is consumer 1 is probably negative. Okay, you plug this in the first one, in here, and then you get as an outcome the following equation: 1x1 divided by u1 y1 minus u1 x1 divided by u1 y1. And this x2 is condition here. u1 x2 is here. Here 2. And so when we normalize this with the mu dividing by u1 y1, with this condition for consumer 1, and this has to be equal to the utility, marginal utility of consumer 2 for x2, divided by u2 y2, minus marginal utility here, u2 y2. Okay. So let's interpret this. And this yields, so this first order condition yields a Pareto efficient allocation of the two groups. There you get Pareto efficient allocation. Of the groups. Now, let's compare the two and understand the two conditions. So this one is the market condition which we have here, which doesn't take into account these externalities. This is just the marginal rate of substitution. How the two consumers are willing to exchange the two goods in the market, which is equal to the price ratio, if there's no intervention regarding the externalities. If a social debtor takes into account these externalities, what we do is we basically add here, because u1 with respect to x2 is negative, okay? So we add this here. Okay? So u1, x2 we have seen here. This is something negative. Okay? So we add this here, and this makes our consumption of good x decreasing. So the higher marginal utility means lower consumption. And same thing here. So in terms of y, for the goose, you reduce consumption of x, which means you have to increase the consumption of y.
So what But what is the interpretation of the second term?
So here, because you increase, you have this one is negative, you add it here. No? You want x2 is negative, so this is externality. So you subtract it, which means it becomes larger. Becomes larger means you have a higher marginal utility for x, consumption of x, which means higher marginal utility corresponds to lower units of consumption, because we have a concave utility. So the first units of consumption give you a larger marginal utility than the last unit. This idea, you go home, example I give for the undergrads always, you go home for lunch, you're hungry, you start to eat. So the first hamburger you eat, the first patty of meat is more valuable to the second and the third. At some point in time you're satisfied, so in one more patty gives you a negative utility, okay? But the first unit of food is always one which you most enjoy. So this is higher marginal utility. Since you increase this, you add this is negative, so the minus becomes positive, you add it here, you have a higher marginal utility for x. Higher marginal utility for x means lower amount of x consumed. So it goes down, consumption of x goes down, consumption of y increases in turn, and like this you get in equilibrium, the social bladder shifts consumption from x for both consumers to 1. And it's reflected in this first order condition of the social bladder. Again, so intuitively it makes sense. Well, what we would say, intuitively you have negative externality, so probably you're better off to consume less of the goods that causes the negative externality and more of the other good. And formally we see that this is actually what is true and not mine. And how can we get this? So the question is, can we impose this? So how can we induce a Pareto efficient outcome? Pareto efficiency in a market outcome? Because the main problem here is, well, if we have the social planner running the economy, we are basically, so in some sense we like this as a guide to see what's the best possible thing we can achieve in an economy. But as economists, we also hate the social planner because this is communism. We have a guy sitting in Moscow telling us what to consume. This is your life. We want to take our decisions, but then the question is, can we implement this as a market solution? How do we implement this as a market solution? How is it possible? Is it possible to reduce Pareto efficiency in a market outcome? Okay. Well, first solution. There will be two solutions. One is, well, create a market for the externalities. Simply create another market. This is like for these, the greenhouse emissions people are emitting, so you can forbid it, but then you cannot produce, so firms that want to produce, so what do? You create a market. You have these emission certificates, people can buy them, firms get it assigned up to a certain amount, but the quantity is reduced over time, so in order to get for the firms to produce greener. Okay, this is the solution here. Create a market for the externality.
Okay. But in that case, for example, in some way it's a state-based answer because the state had to.
Yes, there's still the social planner.
Yeah, it's
later you take the decision.
yeah.
But sometimes you can, if you really like your noise or your smoke, you can keep smoking, but you pay much more money. So you can still smoke, but the taxes are so high, so it's but you pay much less. So now you decide. If you value good X so much that you're willing to reduce your consumption with Y to consume more of X because it's now more expensive, because you have this levy of the externality on top of the price. Okay, so you can do this, but now it's your choice. Before the social planner tells you what to do, now it's your choice. The difference is one you impose it, you tell them what to consume, and others you create incentives to consume less, but you still could consume more. No? Those are the goods. Called the right to buzzer. A little bit casual, but okay. The right to buzzer. Put in,
Music.
yeah, right to buzzer H1 and H2 respectively. And 2 respectively. H2 can buzzer H1 and H1 can buzzer H2. With prices P1 and P2. Prices P1 and P2. Okay. Then again, because now we have the market, the variation equilibrium will be efficient. Variation equilibrium. Equilibrium would be
Is it right? So what?
the right to buzzer. The right to buzzer.
Maybe for someone the utilities maximize the more they bother.
Yeah, exactly. You're not going to do this. If you pay for it, you do it. Now think about it. If you go on the motor of the highway, the speed limit is saying 120. But you know, if you go 150, maximum fine is 50, no points will be deducted. So most people have a speed limit of 150. If you go faster, you have people going faster, but then at some point in time, they take away your driving license or they put you into chain. But there are people going faster, so if you pay the fine, you can do whatever. You know? There's a chance that you are not detected, because not everybody is detected, caught who is going too fast. Now it's your choice. With this individual freedom, which is from the economic point of view better usually. Because you decide based on your preferences. So what does H1 do? So now we maximize utility for the two H's. Put the first order conditions together and see that we get the same conditions that we got here. And so everything is good. So, for H1, first order conditions are utility 1, x1, maximize, so maybe I have to put the maximization problem first. Sorry. H1's maximization problem, so H1 was right, but here I put the maximization problem first, before writing down the first order conditions. So now he chooses x1, y1, and x2, which is the amount of good x which he buys, so it has to be the same, but how much to bother H2 basically. So we get utility of H1, x1, y1, x2, subject 2, and now the budget constraint becomes interesting. You pay price x for good 1, for good x, price y, y1 and P2 x1, which means you have to pay this compensation for consumer 2 because of the externality. And this has to be smaller or equal to your income. Your income is selling the initial endowments of x.
That's the agent costing the externality. That's the agent costing the externality to our.
Here he pays for it. H1 causes externality x1 by consumption, so he pays not only px for this x1, but he also pays the cost of the externality to h2.
Yeah, so this is the one causing the noise, that's why the x2 is positive for him.
No, x2 is actually h2's x. So we'll see how it means here. Here it comes up. So x2 wasn't there yet. This is the income of selling the initial endowment of good x in the market. This is the one of selling the one of y. And now he gets this additional income, which consumer 2 pays for this x2. So consumer 2 consumes x2 and pays off consumer 1. So this is the part which is payoffs that H1 receives due to the externalities that H2 causes on H1. And then we get first order conditions, and now yes, so we get them. With respect to P1, x1 equal to lambda 1, px plus P2, P2, P1 by 1. Since this x2 is part of the utility function, we make it also for consumer one able to choose this, although it's not really him who's choosing, I don't know. And U1 with respect to x2 is minus number 1 and P1.
Professor, can you repeat
Yes.
the part of the,
So here we have, this is, so without the x2 it's the standard part, so this part goes away, this is the standard constraint we had before. Now we have, the consumer also has to pay for his externality, because by consuming x1 he causes an externality on consumer 2, this is what he pays to consumer 2. But he has an additional income, because the externalities that consumer 2 causes on consumer 1, consumer 2 has to compensate consumer 1 with this payment P1 x2. There's an additional income for consumer 1. And now the first order conditions are, these are the standard ones, and this is assuming that he can also choose this x2. Because it's part of his utility function, so it also intervenes in his solution. From this part, which is the one which we should get, because this is actually what is the marginal rate of consumption, because this one is actually chosen by consumer 2. But in equilibrium, this condition has to hold. So here from this one we get the marginal rate of substitution like usual. But now we get it with the Px plus P2 over Py. So before we had the market solution without externality, we had this one. And now we add the price here. So this price becomes higher, which means higher marginal utility, lower consumption. And then you do the same for consumer 2, H2. And you get U2 x2 over U2 y2 is equal to Px plus P1 just by solving the problem analogously, changing the sub-indices. And what else do we get? And now we need this third condition. The third condition tells us, moreover, this condition here, the third one, which are separated for both consumers, you get it. So you get minus P1 over Py. So what I do is, I combine these two here, okay? I get minus P1 over Py is equal to this derivative of the utility x2 divided by P1 by 1, and minus P2 over Py is equal to the utility of 2 with respect to x1 over U2 by 2. Okay, so this things should be consistent. Good. Together, and now you can put this together because now you have an expression for Py. P1 over Py and P2 over Py. So what you will get is the following. Together this yields. So what we get overall is the following condition. And this you will see is exactly the same one that we get from the social planner. So from the social planner we get this condition, and here we get this one. Once you have the market for the externality, you get the same solution as the social planner does. Minus 2 x1 over U2. Okay? This is the same solution as the social planner got, so now we get rate efficiency. Okay? set the right incentives, and like by setting the right incentives, you can then implement this. In the economy, you don't need to have a social plan. The main problem with the social planner in general is that the social planner has to have so much information that in general there will be no agent in the economy who has all this information to take the decision. So it's better to delegate these decisions to the individuals by setting the right incentives with these prices P1 and P2. Like this, each individual in the economy decides personally for him or herself what to do, given the prices, what is my optimal consumption, and there's no need to have one central guy who maybe doesn't know everything, because you need so much information and then implement it to make sure that everybody consumes the right amount. This is not possible in general. And we have seen this in reality actually. No?
It's easier to write with Boolean tax and that's.
This is the second. Exactly.
Professor, what says there?
Together this yields,
No.
and here get
How
very
about that?
efficient,
How about that?
since identical to the social planner solution.
That's right.
Moreover,
Or, sorry.
well, the second solution to this problem is the Bigot tax, which is what I said. Bigot tax. So what is a Bigot tax? The economist Bigot invented this tax, and after this we do the break. And the production externality, so I give an example now to show you also that we can have production externalities. PIGO, P-I-G-O. Okay. Suppose firm 1 produces some output which imposes a cost on firm 2. It would be the chemical factory in the fish. Firm 1 produces output X, which imposes a cost EX on firm 2, which produces Y. Firm 1 produces some output X, which imposes a cost E of X on firm 2, which produces Y. Firms maximize profits. Okay. Maximize by choosing X from 1, which is equal to P of X, X minus C of X, and from 2, output Y is Py times Y minus C of Y minus E of X. So this is a negative externality. So you get first order conditions, which are marginal cost, Px is equal to the price, marginal cost is equal to the price, and the externality is not taken into account. How can we take into account the externality? Let's first here and
We try to tax that equals the amount.
to the firm 1. So, rate efficient solution is a social planner again, and then we impose the tax. Rate efficient solution of the social planner. What would a social planner do? The social planner would maximize the sum of profits in this economy, and like this he gets a better solution because the externality is taken into account. The social planner chooses X and Y simultaneously, maximizing PXX minus CX plus PYY minus CY all the revenues we would sold, X and Y, and the cost for with X, cost for with Y, and with externality. First order conditions, Y to C prime Y, and Px now is equal to C prime X plus E prime X. Now the social planner achieves that these costs, the total social cost of this production of good X, which is the marginal cost of the production, plus the externality I taken the price reflects both the marginal cost, which are the production cost, the direct production cost, and the indirect effect of X production on term 2's output, which is reduced. So this is a social cost, which is taken into account by the social planner, and like this, the price for good X increases, and the marginal cost, again, higher marginal cost, higher price, and will reduce less. So the price of good X equals the social marginal cost, social marginal cost. And well, you can also get the tax, so market outcomes is good tax. This would be good tax. T equal to E prime X per unit of X produced. Of X produced. And then you get Px is equal to C prime X plus Tx plus T. We get that then the market outcome and the social planner outcome cancel. How does this look like? E prime X, E prime X. So we have this is Px minus C prime X equal to pi 1 prime, and this will be the market outcome. So when the price of the good is equal to the marginal cost of its production, you get the market outcome without taking into account the externality. Okay? This is called Px in the market. What's the sort of the optimal outcome? You shift down, so you have Ex, E prime X, and E prime X. You want to get here, what you do is you shift down this by an amount equal to T equal to E prime X. Okay, and then you get to this efficient outcome, so the efficient outcome X here. Here we have this. The second line, so the second profit line here is Px minus C prime X minus E prime X is equal to 0. And this will be this, so you shift this here, and then we go from this condition with Px minus C prime X is 0. Px minus C prime X minus E prime X is equal to 0. So you charge the entire social marginal cost to the front, and then you get this efficient outcome. And then there is one last thing which I will not write down, but I explain it because you all know this already, you've heard about it, which is the cost theorem. And the cost theorem tells us, well, as long as the drain of the externality occurs when we have property rights allocated. What you need to do, you allocate property rights, you can either consume the good X or reduce X and create the externality, but you have to pay the other guy off, compensate him. Or the person which is affected by the externality has to pay for you to stop exerting the externality. One way or another, you arrive at the optimal solution. And what you require, and this is something which is an assumption which in reality is not always fulfilled, is you need like quasi-linear preferences. Quasi-linear preferences with respect to a numerator, you cannot read something. Social marginal cost, which is market outcome, this P good tax, T is E prime X, per unit of X produced. Yeah, social marginal cost, and here's Pareto efficient solution of a social dilemma.
That will be the new price of X, including the tax.
Which one? This one is px minus c prime x minus c prime x is 0. Px minus c prime x, so you not only subtract c prime x like in this condition, but you also subtract c prime x.
You're translating the cost of the generic to the one that's costing.
So when can you compensate this externality between the two firms? You need quasi-linear preferences, which means that both firms or both consumers have to value money in the same way. If we value money in the same way, or the externality, then we can compensate each other with money. But if this is not the case, then rich consumers, for whom the value of money is lower, so $1 extra euro in Europe or in the US is less valuable than in African countries or Latin American countries or some Asian countries. What happens then is, rich countries pay the co-countries option. Because for me, paying something to get rid of this whatever type of externality, let's say toxic waste, you dump it like in India, you have many waste dumps where rich countries pay off poor countries just to dump the waste there, because then it's a lot of money for us to live, because we don't value €1 in the same way. So this is the main problem of the cost view of this market solution, because then rich countries pay off poor countries, so pollution and all the tax stuff which on one goes to poor countries. Because they value $1, €1 more than rich countries. And this is bad outcome.
That was a theory, in practice works better reaching firms of the same country, for example.
Exactly. With among firms of the same country,
And
or
same size.
exactly, or also when consumers the same thing. So if you have the